Sunday, May 21st, 2023.
You are listening to Weather with Enthusiasm. The following comes from the IPCC.
Since the 1800s, the Earth's average temperature has increased by 1.1 degrees Celsius. Scientists expect that an increase beyond 1.5 degrees Celsius would lead to a series of dangerous tipping points. The following segment is about 3 minutes long, a little bit longer than 3 minutes. The information comes from the Washington Post. It discusses the developing El Nino and the possible impacts it might have on the world. As many know already, the world is going through a tremendous transition right now. We were under the influence of a La Nina weather pattern, colder ocean water temperatures over the past 3 years. Despite that, we've managed to see the warmest global in terms of the past 8 years. This has been the warmest 8-year period on record, says the Washington Post. The warmest year on record in terms of looking at it at 1 year was back in 2016. That was also the last time we had an El Nino. The La Nina weather pattern, which is the opposite of El Nino, came to an end in March, finally, after 3 years. The ocean water temperatures have been going way up. They reached their peak in April, at least on the very bottom of the ocean. National Weather Service is forecasting a El Nino to develop over the summer months. In fact, they're forecasting a strong El Nino to develop. This is going to be a significant change. El Nino brings warm ocean water temperatures, the East Pacific and the Central Pacific Ocean. The water temperatures become warmer, and it causes extreme weather to happen across the globe. This has nothing to do with man-made greenhouse gases. Any man-made greenhouse gases will probably add on to this whole thing. But this El Nino weather pattern is expected to develop and will impact, it usually impacts the area for up to 1 year. And if it indeed is a strong El Nino, so we'll be looking at 2024 with an increase in global temperatures. So for a temporary period of time, the global temperature may actually pass 1.5 degrees Celsius higher than what it was in the pre-industrial years, which they're taking the average from 1850 to the year 1900. So we're right now at 1.2 degrees Celsius, 1.2 degrees warmer than that. And over the next several years, there's a 68 to 98% chance, I've been looking at different statistics, that we're going to be seeing the warmest year on record. And the temperatures may also go up to 1.8 degrees Celsius, somewhere between 1.3 and 1.8 degrees Celsius warmer than in the late 1800s. That's what's expected to happen sometime between now and the year 2028, sometime within the next 5 years. This is only a temporary thing. The question is, what is going to be in store for us over the next several years? So, over here in the Midwest and much of the world, the main driving force behind weather is the jet stream. When you're dealing with hurricanes and tropical weather, the jet stream is barely visible at all. There's really is no jet stream. In fact, it's even difficult to have accurate computer models in that part of the world, probably because there really is no jet stream down there. Any jet stream there is, it's very weak, and the main action is going on in the mid-latitudes where the jet stream is. So, what impact will increased global temperatures have on the jet stream? Part of global warming is that the Arctic is actually warming possibly 3 times quicker than any other part of the world. Maybe the number is even more than that. So what's happening is, if the Arctic is becoming that much warmer, so then you would think the contrast in temperatures between the Arctic and the South is going to be less, and the jet stream gets its energy from contrast in temperatures. So the jet stream should become weaker. There are those who say that. I've read about that. The Washington Post, we have meteorologist Matthew. He has written an enormous amount of articles on weather, amazing articles, very well written. And occasionally it does go into this climate change. So he's explained, or he's taking the side that the greenhouse gases are having a stronger impact. Temperatures are warming quicker in the Arctic. He's saying that is likely going to cause a wavy jet stream.
The following comes from the IPCC.
A carbon sink is anything that absorbs more carbon from the atmosphere than it releases. Expanding carbon sinks is a key strategy for tackling climate change and stabilizing the climate. Forests, wetlands, oceans, and soil are the world's largest carbon sinks. We are now going to read about all this, the jet stream in Alaska and global warming in Alaska, from the Washington Post. To hear more about all that stuff in Alaska, I'm going to read an article This article was written a while back. It was written by Matthew Capucci, Juliet Alperin, Andrew Friedman, and Brady Dennis. I'm not going to read the whole thing, but here's the paragraph here. The nation's 49th state is warming faster than any other, having heated up more than 2 degrees Celsius. This is as of the year 2019, 3.6 degrees Fahrenheit over the past century, double the global average. And parts of the state, including its far northern reaches, have warmed even more rapidly in recent decades. This trend, driven in part by the burning of fossil fuels, is transforming the nation's only Arctic state. Scientists around the world, including in the U.S. government, predict the warming will continue unless countries drastically reduce their greenhouse gases emissions in coming years. Here's another interesting paragraph. Much of northern and central Alaska is covered by permanently frozen soil known as permafrost. When this icy soil melts, the organic matter within it decomposes and releases long-buried stores of greenhouse gases, including carbon dioxide and methane. This in turn speeds up global warming. Scientists are increasing their focus on the pace and extent of permafrost melt. Atop the permafrost sits an insulating layer of moss and lichen a few inches thick. In the summer, unusually warm temperatures and scant rainfall have made it a breeding ground for blazes. The weather has been impacting fire behavior a lot. Salmon have been reportedly dying, suffocating as water temperatures climb and less dissolved oxygen remains in the water. The following discusses global warming and brings one example of how complex the situation really is. Global warming, they say, also increases drought. Drought also could increase dust storms. The whole thing is that dust in the atmosphere acts as a cloud seed, and it actually could produce rain. But because of that, it would decrease, scientists say, there will be less hurricanes when there's dust in the atmosphere because the dust encourages the moisture to condense and come down as rain early, so no real big storm ever develops. So it's increasing rain. It's more like there's more rain, but there's less destructive storms. So I don't see how anyone could really know exactly how this is, what's going to happen, because there's so many things going on and each thing affects the other thing. So this is just one perfect example where you have a dust storm. You have the Sahara dust that amazingly every year it blows up into the atmosphere, travels thousands of miles across the Atlantic Ocean, makes its way into Mexico, a lot of times into the Gulf Coast states. We've had years where it made its way all the way up into the Chicago area. I believe that happened in 2020. It's just tremendous stuff. And the dust, it has different effects in regards to the rain. On one hand, it increases rainfall, but on the other hand, it decreases the intensity of storms. So we have the greenhouse gases increasing global warming. Okay, temperatures are becoming warmer, so storms are going to become stronger. But if global warming is also producing more dust in the atmosphere, that's going to decrease the chances of a hurricane. And this is just one example. There's so many. It's so complicated. No one can know anything for sure. Hurricanes that do develop, so people will say that there's more energy to the hurricane, but in regards to exactly how everything's going to play out, there's just so many variables. I'm going to read you something from AccuWeather that just blew my mind. It says here, pre-season tropical development has become all the rage in recent years. And following a post-verified storm from January... Now listen to this storm of January. We're ending that paragraph. Go on to the next one. During the middle of January, analysis of a storm that formed just off the coast of the northeastern United States that was on AccuWeather's watchful eye revealed to meteorologists at the National Hurricane Center that the system was indeed tropical. Since the storm was confirmed months after dissipating over the Atlantic Canada, it did not acquire a name, but was the first tropical depression and storm of the 2023 season. Meaning this thing really should have had a name, but it never did. It's just amazing. This thing formed in... Since when do tropical storms form in January? And even if they do form in January, at least form in the tropics, or at least form in a subtropical area off the Florida coast, off the mid-Atlantic, not the mid-Atlantic coast. That's way too far north. This wasn't even the mid-Atlantic. This was the northeast coast. The northeast coast. It's like, what in the world is going on here? The following discusses the minimal temperatures. Usually, these are the minimal temperatures necessary, the water temperatures, in order to produce a tropical storm. A temperature of 77 to 78 degrees Fahrenheit is the agreed upon approximate cutoff amongst the meteorological community for full tropical development. So here's the thing. In America, where we go by the Fahrenheit system, so we generally will say 80 degrees or higher is tropical storm development. The rest of the world goes by the Celsius system, so they use 25 degrees Celsius. People like to use like increments of 5 or increments of 10. So 25 degrees Celsius translates to 77 degrees Fahrenheit. And it is possible to get a tropical storm at 77. They're saying 77 or 78 degrees Fahrenheit. Now here we're saying that's the agreed upon approximate cutoff amongst the meteorological community for full tropical development. However, there are exceptions to every rule. Farther north, waters trend cooler, but as with the tropical storm in January over the northwestern Atlantic, water temperatures were significantly lower than the threshold. It's amazing. What were the water temperatures? Right, it was the northeast. It's in the middle of winter, the northeast part of the United States. I happened to notice a week or two ago this water temperatures in the 80s. If you go about 100 or 200 miles east of Baltimore, you hit water temperatures in the 80s. But then when you get close to the coast, those temperatures drop big time, maybe even the 50s. Anyways, currently in our country, we have the heavy rains taking place in the southeast portions of the United States for this week. A city like Jacksonville, Florida. Temperatures are going to get real warm in the Midwest, but nothing record-breaking or anything like that. And I'm not aware of anything too extreme. The Pacific Northwest is above normal, but I haven't seen anything that extreme. And we'll just have to wait for next week. Nothing too extreme this week. following is an extract taken from AccuWeather, and it discusses the potential for a tropical system sometime within the next week or two. In the case of potential tropical development, during the last week or so of May to early June in the southeast coastal waters, a broad southward dip in the jet stream will develop and persist. Very interesting weather pattern. It doesn't sound like a summertime weather pattern, but this pattern will help to lower atmospheric pressure in the region. Rising air generated by the lower pressure will cause pockets of showers and thunderstorms to erupt over land and sea in the region. Any one of these clusters may slowly develop circulation and evolve into a tropical or subtropical system. A subtropical storm has both tropical and non-tropical characteristics. AccuWeather meteorologists have assigned a low chance of tropical development along the southern Atlantic coast from May 23rd to May 28th. It is possible that more than one system may try to form over the same period into early June. The first two names on the list of tropical storms for the 2023 Atlantic hurricane season are Arlene and Brett. As of Sunday, May 21st, the National Hurricane Center was not outlining any area for potential tropical activity for this week. Regardless of whether disturbances in the pattern are linked to the tropics or not, impacts along the southern Atlantic coast can be particularly disruptive for outdoor activities in the days prior to and during the extended Memorial Day weekend. Johnson Levine said, areas of rain, gusty thunderstorms, and building seas and rough surf are likely as the broad area of low pressure develops in the region this week. Downpours and thunderstorm activity will extend well beyond the southern Atlantic coast and perhaps as far to the west as the southern Appalachians, the central Gulf Coast, and perhaps into the Carolinas. You've been listening to the podcast, Weather with Enthusiasm. This trailer was updated at the very end of January 2023.
We have two things going on. We have evaporative cooling and we also have dynamic cooling, and the two are coming together to produce a major snowstorm in the deep south. The only time you could blame cold air on climate change is when it's a result of the stratosphere warming, which is what causes all the Arctic air to come down south. The way to get a 6-inch snowstorm here in the Midwest and in the southern plains has always been you need 3 ingredients. It's hard to believe the numbers that are being forecasted.
Several additional feet of snow is expected by Monday morning.
Yes!
Hey, we have a special guest on our show. What is your name?
Kitabis.
27.1 barometric pressure. Feet of snow are falling in Japan.
Oh my God.
That's a time of celebration.
Just Google weather with enthusiasm and they're all going to come up.
We receive unimaginable amounts of hate and threats. We can no longer look away from the obvious fact that we also need to change our behavior.
We leave off with the question, is the behavior she's referring to, could it mean the behavior and how we treat each other? That's just a thought. I wish everyone a great week.
We can no longer look away from the obvious fact that we also need to change our behavior.
Are capturing, sequestering carbon from biofuels and bioenergy plants. Carbon removal could slow, limit, or even reverse climate change.